Integrate 0 to 1 cot inverse of 1 minus x plus x squared into dx. We have one formula, cot inverse of x is equal to tan inverse of 1 by x where x greater than 0. So let I equal to 0 to 1 cot inverse, you can write it as tan inverse of 1 by 1 minus x squared 1 plus x squared minus x into dx, and the numerator 1 can be written as x minus x minus 1, adding and subtracting x here, and the denominator when you take x common it will be x into x minus 1. Now here we know another formula, tan inverse x minus tan inverse y equal to tan inverse of x minus y by 1 plus xy. So here it's x and this is y. So applying this formula here, so we get tan inverse of x minus tan inverse of x minus 1. The limit is 0 to 1 tan inverse of x minus tan inverse of x minus 1 into dx. So here consider this integral the same, and this integral applying the property, this property here, and instead of x you write 1 minus x minus 1. So 1 and minus 1 will get cancelled. We'll have tan inverse of minus x. So tan inverse of minus x is minus tan inverse x. We have already minus outside, so this will become plus tan inverse of x dx. So here we have 2 tan inverse of x dx, 0 to 1, 2 into tan inverse of x. So here applying the integration by parts method, and u equal to tan inverse of x, because I is inverse and L is logarithmic function, A is algebraic function, T is trigonometric, and E is exponential function. So we have u tan inverse x. When you differentiate, we get du equal to dx by 1 plus x squared, and dv equal to dx, and v equal to x. So when you apply in this formula, we get x into tan inverse x 0 to 1 minus 0 to 1 x dx into x dx by 1 plus x squared. Now in the second term, when you apply the limit for the first term 0 to 1, so tan inverse 1 minus tan inverse 0, 0. So tan inverse 1 is pi by 4, and here minus 1 by 2. Here also 1 plus x squared when you substitute u, and when you differentiate 2x dx is equal to du. So x dx equal to du by 2. So we have to change the limit also. When you apply x is equal to 0, lower limit, and u will become 1. When you substitute here 1 plus x squared equal to u, and when x is equal to 1, u becomes 2 here. So the limit becomes 1 to 2 du by u, and du by u is log u. Now apply the upper limit, log 2 minus log 1, and here 2 and 2 will get cancelled. We have log 1 is 0, so log 2. So the answer is pi by 2 minus log 2.